Good afternoon, everyone. I'm happy to welcome you to another one in the series of International Francqui Professor lecture series. And what we will continue to focus on is on weak newborns, both animals and infants. In this case, we will focus very much on nutritional interventions. First, just to introduce our group in Copenhagen that we work on these newborns is shown here. And now let's turn to what is the main themes regarding the optimal nutrition for these weak, immature or small newborns. So when in a state of birth, we come from a state of sterile fetus before birth fed parenteral nutrition, where we need to have that somehow transitioned to a state after birth to enteral nutrition. So the state of enteral nutrition with a colonized newborn fed oral milk is a state where we need to adapt the organism to be fed milk and microbiota over some days or weeks. And of course, the more weak and the more immature the newborn is, the more difficult it is to make this transition from parenteral nutrition in utero to enteral nutrition ex utero, especially because we need to interact also with those bacteria around us. So when, what, and how should we feed with milk, and how should we colonize with bacteria? At least feeding with milk we can steer and control. Colonizing with bacteria is more difficult. What we conclude generally across the different species is that we should feed enterally early, even for those very weak newborns. We should feed a protective milk, and we should try to control gut colonization. And let me now focus on these two different species mainly. Infants, which can be growth restricted or not growth restricted at birth, and likewise with piglets, that can be both immature and also small, as shown in this picture here. Now, shortly after birth, when it comes to adaptation of the small intestine, I like to show you this exciting picture here that basically shows how dramatic the change in intestinal weight is just after birth, at least in piglets. We don't know exactly if this is the same in infants, but there's an absolutely dramatic weight increase in the intestinal weight just after birth. So when we take a cross-section of the intestine, it may look something like this, with the tall villi before birth and small crypts, which is transitioned into smaller villi and taller crypts. And then at the time of weaning, it may look more like this, where we have very short villi and tall crypts, and then adaptation to the adult stage. But so the interesting question here is the time around birth. Is it stimulated by nutrition, or is it determined by something completely else that the intestine grows so dramatically? So what I'll show you here is the response to the first enteral milk after birth, and the response of the intestinal mucosa in its growth. And we compare here the unfed newborn animal with the newborn animal, in this case, pigs that are fed with colostrum. And this is published in various works previously. So when we compare the term newborn pigs with the fetal pigs, where we feed them in utero, in the mother's womb, and with those that are born immature or preterm at 90% gestation, and then finally compare it with those that are first fed parenteral, where we continue the maternal parenteral nutrition after birth. If we compare these four groups, we will have an indication of what determines this massive growth of the small intestine just after birth. And what I show you here is this proportion of the intestinal mucosa in the colostrum fed versus the unfed animal. A massive increase in the term piglets. And interestingly, intestine also grows before birth if you feed those piglets before they are born. So these are studies where we put in catheters into the esophagus of the piglets before birth and try to feed them before birth, and the intestine grows equally fast before birth as it just as after birth. Interestingly, also the intestine grows just as dramatic when we feed the preterm immature pig as when we feed the term pig or the fetus. Only when we first give a period of parenteral nutrition, that is nutrition via the bloodstream, not via the mouth, then the response to the intestinal mucosa is much less when we start feeding with enteral nutrition. And this is actually one of the reasons why we need to feed enterally for the weak newborn, even if it's sometimes difficult, which we will come back to a little later. So let's turn to these newborn pigs and see how they respond to their first diet in the first 2 days after birth. This may or may not again be similar situation in infants, but what is important is that it's diet dependent. So we compare here in an experiment newborns with pigs that are fed 2 days sow's colostrum, 2 days cow colostrum, colostrum from another species, proserum from a pig, and then 2 days of formula or milk replacer. So when we feed these 3 different diets that are quite different in their contents of bioactive milk factors, then the response to the mucosa in grams per kilogram of body weight is exactly the same. So this indicates that the bioactivity of the sow and cow colostrum is not what it creates the growth of the intestine. It is actually the nutrients themselves. So in this study, the nutrients were adjusted to the same level in the 3 different diets. However, when we look at functional characteristics of the mucosa, then it's vastly different. So even if the mucosa grows the same, the maltase activity as one of many functional markers of the mucosa is vastly different between the 3 different diets. In this case, actually the pigs fed 2 days with cow colostrum is the one that has the highest growth of the mucosa. Now let's take a look in the same experiment, the absorption of last proteins this time exemplified by BSA and HSA. And what we see is that those that are fed formula have a much lower absorption of protein macromolecules, indicative of a dysfunctional enterocyte or gut cells. So this is the case just after birth, as well as 12 hours later, that the response of protein absorption is by far the biggest in those that are actually fed sow's colostrum. So while the growth of the intestine was the same between the 3 different diets, their functional characteristics when it comes to both digestive function, indicated by maltase activity, and the absorption of large protein, indicated by BSA and HSA absorption, is much higher in their own species colostrum. If we take a look at this diet-dependent billet structure in term pigs, that was the same between the 3 different diets, then it looks like this in newborns up here, and then after 2 days of feeding with these different diets, the mucosa looks like this. As you can see, while the mucosa may have the same weight, it actually looks quite different. So this is the first indication that it's maybe important what we feed. It's not only important that we feed. So the development of this enteral food response just after birth may be able to be taken care of by giving a suboptimal milk replacer, but it's not optimal. So what we find is that when we feed it to term pigs that are robust, it's relatively okay to feed on an alternative diet. It is possible to feed an alternative diet. It's maybe also okay if we feed it to fetal pigs, but especially when we feed it to immature newborns, then we have a problem if we feed a suboptimal diet. And I'll show you some more examples that this quality of the first enteral milk feeding is very much a sensitive issue when we have immature newborns, which we have to variable degrees. Now let me show you the growth of these preterm and term pigs when we've compared them, the simple body growth. So what you see here is that when we give them the same feeding and rearing conditions the immature newborns versus the term newborns, then the growth rate is markedly different between the two different states. So, and this is not because we've given them different amounts and type of nutrients, but because we've given them exactly the same. So there's something wrong with their physiology when they are immature that makes them grow slower. So what is wrong with their physiology? It in principle could be related to all these organs that could have a problem. And we've studied over the years also really what it means to be preterm with regards to the development of all these organs. And now what I'll focus on in this talk is mainly the gut development, because after all, the gut, of course, is very important when it comes to adapting the newborn to its new diet. So is it possible that mother's milk, as we indicated before, is protecting the newborn and maybe even protecting it against invasive bacteria? Not only that it matures the intestine, but it also protects it against bacteria. So I'll here show you some studies that we did on comparing infant formula with mother's own colostrum. And when we feed mother's own colostrum, a cross-section of the intestine may look like this, and we've here also stained for bacteria. And you can maybe see in the picture here that it seems like the mucosa is trapping the microbiota. So a sort of milk prebiotics or local mucins is trapping the bacteria and keeping them away from the mucosal lining. If we take a closer look, in this case, we stain for Clostridia. It is indicated here that Clostridia are trapped by milk components. So we believe that that is one of the reasons why it seems, especially in the immature newborns, that it's so important with the quality of the diet, in this case being mother's own colostrum. If we compare that to the infant formula situation, then we see a much more open mucosa there, maybe even mild atrophy. And this is just 2 days after the start of feeding, just after birth, where we can see this massive difference in the mucosa. If we take a very close look at the mucosa, then it is indicated here that there is close epithelial contact of the bacteria with the mucosal lining, which of course potentially will create inflammation and bacterial translocation. When we have compared in these different studies colostrum-fed animals with formula-fed animals, we also find that the synthesis of the mucins in the mucosal lining, in this case illustrated here by red color, is much higher when we feed colostrum versus when we feed formula. So the lesson is it's important to feed mother's milk simply because it stimulates mucin production and keeps bacteria away from the mucosal lining. If we feed formula and stain for bacteria across the intestine in a cross-section that looks like this, it looks, we can see the difference to the pictures that I showed you before. What we see is that such a cross-section that are fed formula for just 2 days after an immature birth is losing the muscle tonus, it's having dilated vessels, it's having a very open atrophic mucosa through which all these bacteria stained in red here can penetrate deep down into the mucosa. So there is this deep penetration of bacteria into the mucosa. There's even translocation of bacteria indicated here by bacteria on the outside of that intestine. So, and of course, there is a possibility that this may create sepsis and bacteremia for such a newborn. And this holds true for piglets as well as for infants. So, and this made us many years ago develop this model of necrotizing enterocolitis, which was very much dependent on not feeding the optimal milk. And we know that from infants also that this terrible disease develops when we feed the infant, have bacterial colonization and have bacterial infection in the intestine that creates inflammation. So let me just show you how this looks in infants and pigs, this terrible disease that is very much diet and feeding dependent in the immature newborns. So about 10% of the very extreme immature newborns will get this disease. In infants and pigs, it looks like this when we have this gas production in necrotizing enterocolitis, When we open up the intestine may have air bubbles on the intestinal wall for both infants and pigs. A healthy pig may look like this 2 days after birth. And when these newborns develop necrotizing enterocolitis, it looks like this. So preterm pigs have a very sensitive intestine to necrotizing enterocolitis when they are fed a suboptimal diet, more sensitive even than infants, and that's why we can also use them as good models for the optimal diet, even for infants. And when we have this situation in pigs and in infants, we may want to resect the gut and leave the newborn with an ileostomy, because otherwise the newborn may die. And therefore, we also developed some years ago a preterm pig model of intestinal resection. That is a model for some of these infants that are left with only part of their intestine after NEC. So preterm infants and necrotizing enterocolitis, I'll just summarize some of these characteristics of this important feeding-related disease in immature newborns. It is related to immature gut and newborns, suboptimal diet and feeding procedures, and a bacterial dysbiosis. These are the three basic conditions that leads to NEC in immature newborns. The factors that may prevent or use to treat the disease is cardiovascular and fluid support, a changed optimal diet and feeding, installation of antibiotics and pre and probiotics to modulate the gut microbiota, and then drainage and gut resection in the worst cases. There's a series of predisposing factors and diseases that includes a whole series of diseases that I won't go into the detail with, but this is mainly related to all the detailed disease conditions that we know from infant that leads to this disease. Lung disease, cardiovascular disease, brain diseases, inflammation in the mother, growth restriction of the fetus, low temperature of the newborn, and early and late onset sepsis will all help predispose this newborn to develop necrotizing enterocolitis. Once the problem happens, we may get short bowel, as I mentioned before, a resected intestine, dysmetabolic newborn, late onset sepsis and infection, lung diseases, bronchopulmonary dysplasia and chronic lung disease, growth deficits and brain defects. So all sorts of problems that relate to this. And it's all due to inappropriate feeding of an immature newborn. So it presents to us quite a fundamental issue of how we should try and transition this newborn into its healthy state after birth. And this is probably the worst case scenario when this fails completely. Now, if we have a newborn that develops necrotizing enterocolitis, of course, we would want to try and feed this newborn optimally and with the optimal milk. And I'll show you some results where we've compared different sources of milk like we did before. So I showed you previously comparison of sow colostrum, cow colostrum from another species, and then infant formula. But this was in term animals. So term animals do not normally, pigs develop necrotizing enterocolitis, neither do term infants, although occasionally they do. And this is the incidence of necrotizing enterocolitis following these three different diets. So newborns, they of course never develop necrotizing enterocolitis because it's diet dependent. If you feed just sow's colostrum or cow's colostrum, there's usually no development of necrotizing enterocolitis. But if you feed formula, then we have a development which in our system is about 40% develop NEC lesions. What I want to show you here, if we first avoid to feed the newborn a few days, we may think that, well, let's wait to feed the newborn a few days until the intestine matures a little more, and then maybe the incidence of necrotizing enterocolitis would be less. We found exactly the opposite, that when we wait to feed a few days, the incidence of necrotizing enterocolitis increases regardless of the diet that we use. So TPN is here total parenteral nutrition, complete intravenous nutrition. So quite the opposite of what we would expect. And these results have led also to the recommendation that we want to feed the newborn baby and also the newborn pig as soon as possible to avoid detrimental inflammatory reactions in the gastrointestinal tract. So there is an increasing sensitivity to gut inflammatory conditions if we don't feed immediately after birth. Now, why is that? Well, part of it is related to a very high gut permeability just after birth. And I here show you some results from infants on day 2, where we have measured the lactulose mannitol ratio, which is an index of gut permeability, which is much higher in preterm infants relative to term infants 2 days after birth. So the problem is that this gut that has a high permeability just after birth will also be very sensitive to bacterial provocation and stimulation, which may lead to bacterial translocation into the bloodstream, and then not only local gut inflammation, but also systemic and blood inflammation. So we would want to feed the immature newborns, but it's not easy to feed the preterm newborns because the gut is not mature. So when, what, and how should we start feeding, and how should we increase feeding? That is quite a fundamental question for taking care of preterm infants. It, of course, has something to do with the gut function, that it needs to be mature, and we need to have focus on the gut. But it also has something to do with the intermediary metabolism, the body metabolism, with regards to not being coming into a risk of overloading the newborn with nutrients. So this is a careful balance. And it may even affect not only the gut, but also the immune system and organs like the brain if we don't feed correctly. The problem that we have very often with these immature newborns, pigs as well as infants, is that they don't tolerate the feeding. So even if we want to feed, we may not be able to feed, and there's a lot of vomiting and dysmotility. We want the situation of good growth and want to avoid the necrotizing enterocolitis and late onset sepsis, of course, but also we don't want a dysmetabolic state. So if we overfeed this newborn with either parenteral or enteral nutrition, we may easily get into a state of dysmetabolism that will predispose to metabolic complications. And on the other hand, we don't want extra uterine growth restriction where we underfeed the newborn. And one of the reasons that we don't want to do that is because it affects the brain a lot. So we want to predict this condition before it happens and have good biomarkers for the optimal feeding procedures. And that's where the animal studies may also be able to help us to have good predictive biomarkers for the optimal feeding. So is early feeding and diet important? I think I've already convinced you that I believe it is highly important. What I'll show you here is a paper from about 10 years ago, where there was an association study made of the morbidity in preterm infants relative to the intake of mother's own milk during the first days of life. Because the intake of own mother's milk was actually associated with very much a decreased morbidity and mortality in these very immature infants during the first 60 days of life. So the lesson is just a little bit of mother's milk in the first few days may actually have long-term, very serious consequences. Let me show you their results here. So what they showed that, so this is the proportion of infants who survive without any complications. And in this case, they measured complication as neck sepsis and death in these infants. And then they illustrate here 3 groups relative to the amount of mother's milk taken in during the first 5 days of life. And when they have no mother's milk during the first 5 days, the mortality of these immature newborns, or the survival without having any serious complications, was only 30%. So only 30% of these infants survived without serious complications if they didn't have any mother's milk during the first 5 days. If they had less, from or half of their diet as mother's milk and not formula, if they just have half of their diet, then we almost doubled the survival without these serious complications, which is quite a dramatic effect of just a little bit of mother's milk. So it seems like even a little bit of mother's milk is important during the first 5 days of life. And I'll come back to a little later why this may create such dramatic effects to feed the newborn with just a little bit of mother's milk in the first 5 days of life. Some older studies here, classical studies that started this whole interest in breast milk and development of necrotizing enterocolitis was those presented by Alan Lucas many years ago. And I'll just here repeat some of their main conclusions. So what they showed was that exclusively formula-fed babies were 6 to 10 times more common or frequent to have necrotizing enterocolitis. And pasteurized donor milk seemed to be as protective as raw maternal milk. And that is maybe a conclusion that has been questioned since, and I'll come back to that a little later, whether you can just take milk from another mother and pasteurize it and then expect the same effect as mother's own milk. And then finally, they also concluded that the delayed enteral feeding was associated with a lower frequency of necrotizing enterocolitis. However, as I indicated before, this is a very dangerous path to delay the enteral feeding and put them on parenteral nutrition. So this is actually a conclusion that we have completely revised since this was published in about 30 years ago. So even if things are published in the Lancet, you cannot necessarily expect that this is the eternal truth. And we have to say that 2 of these 3 conclusions have been revised in the last 30 years. So in weak newborns, a diet-dependent feeding guideline is highly required, and it's actually very difficult. So what is it with mother's milk that is so important? If we try and illustrate what goes on in the intestine, here we may illustrate it schematically by the presence of bacteria in the gut lumen. We have an underlying immune system, and then we have a mucosa here. And what I want to show you is the differences in this picture relative to when we are feeding formula. There's many aspects to this, but there's maybe 3 or 4 main key components. So if we feed formula, we have a different composition of bacteria. And for example, we will often see in the preterm newborns that we have more Clostridia in the gut. Secondly, as we also indicated before, mother's own milk seems to be able to stimulate the mucosa production and the mucins, which is a protective layer against the bacteria. Finally, we will have less bacterial translocation when we have this less if we feed mother's milk, but we may have a damaged epithelium and bacterial translocation if we feed formula. And finally, it is important to note the risk of inflammatory mediators that will rise in the mucosal wall when we are feeding formula versus human milk. So these are 4 elements that differ between mother's milk feeding and infant formula feeding in both infants and piglets, according to our studies. So why is it then that we should feed the newborn? It's partly simply because we should move bacteria and protect this mucosa. And let me illustrate it like this with this gut here and show you how the bacteria are sitting mainly in the colon region. And we have about 10 to the 10th or 12th density of bacteria in this region. And what we are doing with enteral feeding when we have a normal gut motility and are feeding with a protective milk diet then it looks like this. So the milk is passing down the gut and is basically moving the bacteria away also from the mucosal lining. So we get a subclinical inflammation that is actually helpful for intestinal maturation, and we get a good motility, a stimulated absorption, a homeobiosis when it comes to the microbiome, and a good immunity development. So this is the natural state that we would want to stimulate. However, if we have instead limited feeding and gut dysmotility in an immature newborn, and even feed with an inappropriate diet like infant formula, then the situation looks more like this. We have the infant formula passing down into the gut, and we have a degree of dysmotility and ileus, which also will potentially create excessive proliferation of bacteria, actually over fermentation and proliferation of bacteria, and a more pathological inflammation in the intestine relative to the physiological one that I showed you before with mother's milk. What this pathological inflammation may potentially lead to is further gut motility, maldigestion of nutrients, gut microbiota dysbiosis, and immune defects. So these are some important differences between this limited feeding with formula versus the more physiological feeding with mother's milk. So what if we don't have mother's milk available for these weak newborns? What do we do? Over many years, we worked with many different type diets, and we also tried to feed with human bank milk and colostrum from other species to these preterm pigs to study their incidence of necrotizing enterocolitis. And I here just show you one of the papers from 10 years ago, and we also work with researchers here in Antwerp on many of these studies. So surprisingly, what we found was that human bank milk, human milk and colostrum from a cow both had an ability to decrease the incidence of necrotizing enterocolitis in preterm piglets relative to formula feeding. And the formula was a conventional formula being used for infants at hospitals. So the interesting thing and questions to ask here, does milk work across species? So does it really matter from which species we take the milk? And does it also work across lactational stages, such that we can use more mature milk and also colostrum? We all believe that colostrum is maybe better and has certain milk bioactives, but in this case, human bank milk, which is mature milk from a human milk bank, also was protective against necrotizing enterocolitis, at least in pigs. And then the question also rises whether it matters that this human bank milk was processed and heated and pasteurized. So I'll get back to this possible effect of industrial processing of milk products, what it may do to the bioactivity of these products. But first I'll just indicate again, what is it that is these differences between a natural mother's milk or sow's colostrum, in this case when we're feeding piglets, versus formula. Here we show the uptake capacity of galactose as a marker of glucose uptake capacity. And when we test it at two different time points on day 2, then we see that the uptake capacity for glucose is much higher when we have been feeding a sow's colostrum diet, which of course will have a fundamental influence on the ability of this newborn gut to absorb nutrients if the difference in glucose uptake capacity differs between the two states. What we also saw is that when we have a pure galactose absorptive capacity, then that the colostrum diet facilitates a much higher galactose absorptive capacity in the gut relative to the formula feeding. Also, when it comes to absorption of intact proteins, And here the intake proteins represented by bovine serum albumin and human serum albumin, the uptake capacity to these intake proteins is much higher when the newborns have been fed colostrum relative to formula. So quite impressive effects of diet on the nutrient absorptive capacity of these immature newborns. That made us start looking into how we would use alternative diets for a slow feeding start in newborn infants. And we did these model studies with preterm pigs to try and find out how we could best do it and avoid the serious inflammatory conditions when we have been feeding with infant formula. So we did a series of studies where we did it very gradually, introduced with infant formula or bovine colostrum over the first 5 days after birth, and had the same volume and energy and protein supply to these newborns. And I'll show you here the quite dramatic effects, even when we feed minimal enteral nutrition, a relatively little amount of enteral nutrition, referring back to the studies that I mentioned before, that even a little bit of mother's milk seems to be extremely helpful. So mother's milk here being mimicked by bovine colostrum in this experimental setting. So we have 3 groups here. We have those that have been not fed at all parenteral nutrition, those in red indicating the preterm pigs fed infant formula, and then finally those fed bovine colostrum. So a small volume of formula leads to subclinical NEC lesions. So these are the lesions of NEC in the 3 groups, 0% in those that are fed bovine colostrum, and 60% in those that are fed infant formula. When it comes to gut permeability, you'll all see a big difference between those that are fed formula. Gut permeability much higher in the formula-fed ones versus the colostrum-fed ones. And the number of animals with diarrhea much higher for those fed formula. And IL-8, a marker of inflammatory reaction in the mucosa, significantly higher in those fed formula. Lactose digestive capacity is much lower, which we also indicated in the previous figures that I showed you. And then finally, the galactose absorption that I also showed you some examples of previously from another experiment, higher when the galactose absorptive capacity is different between those that are fed colostrum versus formula, with higher in the blue bars. So the good news is that we may have found here an alternative diet to mother's own milk when we don't have mother's milk available. Because the situation is such that when we have these preterm newborns, we often don't have mother's milk available, or we need to get the milk from a milk bank because the mothers may have no lactation. So we also try to extend this feeding for a longer period in preterm pigs and compared bovine colostrum with human donor milk and infant formula. And I'll just show you the results here again. So the bovine, when it comes to bovine colostrum, the weight gain was much higher when they are fed with bovine colostrum relative to donor milk or infant formula. So quite a dramatic stimulation of growth rate in these preterm newborns when we use the right diet. When we take a look into the intestine and look at these 6 different enzymes, then it's also indicated here that the bovine colostrum group with the black bars are higher for sucrase. They are maybe not changed for maltase, but certainly much higher for lactase, and also higher for the 3 aminopeptidases investigated. So altogether, a better functioning digestive mucosa after feeding colostrum relative to human donor milk and infant formula, so both of them. When it comes to the bacteria that are adhering to the mucosal lining, which we would want to prevent, then the number of bacteria that are adhering that you'll see here indicated in red, then the number of bacteria adhering to the mucosal lining is much higher for the infant formula than it is for the donor milk and bovine colostrum. So generally, overall, you can maybe see that the donor milk was surprisingly similar to the bovine colostrum, but that the formula one is significantly different from most of the parameters. So that's the worst diet. So there is sort of a potential to use the more natural diet, even if it's also pasteurized and processed and from another species like human, when we use it for piglets in these studies. So these are again a picture of some of these preterm pig studies that we did. And this led us finally to do a study in human infants 5 years ago that have now just been completed. And I would love to present you with just some very preliminary results from these trials on bovine colostrum that we were feeding to preterm infants around the world, initially in 2 large trials in Denmark and China in the last 5 years. So the pre-color study used colostrum as the first feed, and this was done to 350 babies less than 1,500 grams. And then the 40 colors trial, 2 different trials where we used colostrum versus formula as an addition to human milk. And this is just an illustration of the trial protocol in the first 4 weeks, where we used colostrum as a first feed or colostrum as a fortifier. And we took plasma and fecal samples, and our aim is now to investigate lots of different factors related to these fecal samples and the blood samples over the next year. So this is now ongoing, but I can show you a few of the clinical results. So the bovine colostrum used as the first feed to preterm infants, the primary endpoint was time to full enteral feeding, and actually there was no difference. So somewhat to our surprise, we did not manage to improve the feeding tolerance and the maturation of the gut by feeding colostrum. Feeding intolerance was very similar and not significantly different. There was a slightly reduced ratio so we had slightly reduced feeding intolerance in the BC group relative to the preterm formula group here. That's the only significant result. But altogether, these results show how difficult it is in human trials to show something that has shown such dramatic effects in animal studies. And whether that is due to a species difference or whether it's due to factors related to the clinical practice is a big question. I think actually it's related to the clinical practice, and that we still actually would have under certain conditions the effects of colostrum, but it may not be possible to use it exactly in the same way as we're doing for the piglets. Let me also show you some of the clinical outcomes here for these 350 babies. And as if you see the p-values here, the clinical outcomes is exactly the same whether you use bovine colostrum or preterm formula as the first feed for these preterm babies. So when we are feeding such a preterm baby, we are in a situation where we would do everything we can to provide mother's milk for the reasons that I mentioned before. So we try to get the mother to pump out and to provide the milk. And if we don't have the mother, we may try a donor milk bank, but most hospitals in the world, maybe they don't have access to human donor milk. So therefore we are left with formula. So when we feed these human babies here, we may add colostrum on top of the mother's milk, and then we may even add formula on top of it also, because the problem is for these babies that they don't tolerate also high amounts of protein, and colostrum is very protein rich relative to formula, so therefore we may have to have such a mixed feeding regimen. And what I'll show you here in the next slide is how we ended up in this trial feeding the babies, because we left the doctors to feed the babies in this manner: first mother's milk, and then bovine colostrum, and then finally formula on top. And what I want to illustrate here is the great diversity of feeding regimens across. This is 175 babies in the bovine colostrum group, and here you see the corresponding 175 babies in the infant formula group. So what is characteristic is that there is a very different way of feeding individual babies, because you adjust the feeding to the clinical condition of the baby. And that makes it very hard to make clinical trials in infants relative to the clinical trials that you have done in piglets, where you can control every factor related to the intake of nutrition. So some of these infants have, you see, received only mother's milk. Others have received almost only formula, and even in the same group here. Some infants have received almost exclusively formula, and others again exclusively mother's milk. So this is probably what makes it so hard to actually demonstrate a beneficial effect of what has been proven in animal models, also in infants. So we are still in doubt whether this will help support the use of bovine colostrum for preterm infants in the future. It is highly variable, and feeding preterm infants is not really an exact science, and it's always difficult to prove effects of specific interventions. Now, finally, we will just discuss a little bit why it is that formula may not be adequate for feeding infants. So we believe that it's not due mainly to the nutrients, it's more due to the milk processing done by the formula industry. And I'll just remind you here all the factors that goes into processing of infant formula before the protein goes into the infant formula. So there's many processing steps that may also damage the bioactive proteins. And therefore, there's been much work in the formula industry to try and produce formulas that are less treated with heat and more gently treated. And so especially for the immature intestine, this milk processing is critical. And I'll show you here some results that we did from preterm pigs that demonstrates how easy it is to affect the quality of the diet with or without gentle heat treatment of the milk. So human donor milk needs to be pasteurized to be sterile, otherwise we don't dare to use it. But is it possible that instead of heat treatment for pasteurizations, that we could do ultraviolet light treatment, which is more gentle, and that would tend to have less damaging effects on all the bioactive factors in the milk? So I show you here a result where we tested heat pasteurized versus raw donor milk versus ultraviolet light in piglets, and then looked at the various parameters in the gut. So the weight gain in these piglets over the first 8 or 9 days was markedly higher when we were feeding raw donor milk relative to the heat pasteurized and ultraviolet light. So the simple fact of heat treatment or pasteurization may actually affect the growth rate. That's the first lesson. When it comes to diarrhea incidence, we also tended to have the lowest diarrhea incidence in those that were fed the raw donor milk, at least here day 4, 5, 6 after start of feeding. We observed then also that those that were fed raw donor milk and UVC treated donor milk had the highest villus height, indicative of better structural development of the gut. And then the diversity of the observed microbiota was also highest in those that were fed raw milk versus the 2 pasteurized group, either heat pasteurized or pasteurized with ultraviolet light, indicating that these pasteurizations, they do affect the microbiota. When we looked at the small intestine and its enzyme activity, we actually saw that the UVC treated milk induced the highest activity on these peptidases in the distal intestine, indicative of beneficial effect of the UVC, at least versus the heat pasteurized group. So donor milk processing does affect the intestinal maturation, and it's very important with the processing of these products. And of course, formula is heavily processed before it gets to both pigs and newborn infants, and therefore the processing itself is part of the problem with these artificial diets. So when we look into the bacteria in these studies in the blood and the bone marrow after mild UVC treatment, we also wanted to know if we could prevent bacterial translocation better by having a more mildly processed milk diet. And we saw in the blood that we could find no difference, and that's often the case when we look in the blood for bacteria, that it's difficult to find them in the right amounts and time. But if we look in the bone marrow here, as we did in this part of the study, we see that the UVC group has less bacteria in the bone marrow relative to the other groups. So we do conclude that the mild heat processing is indeed helpful for protecting the mucosal lining against bacterial adhesion and thereby also bacterial translocation and preventing sepsis. So the feeding effects on the immature gut immunity and brain, because when we have bacteria transmitting to the blood side, it may also affect distant organs like the brain. Let me now just summarize some of the factors that we have put forward in this lecture. We've compared mother's milk and formula. We've tried to describe some of the differences that it makes to feed either mother's milk and formula, and what is the problem with formula. Mother's milk is a natural milk, and formula is a processed milk that may to a various degree have destroyed the bioactive factors in the milk that is able to help protect the intestine from bacterial adhesion. We would want to feed early and slow rather than late and fast when it comes to the detrimental effects, and we would want to facilitate an early and slow colonization rather than a fast and late colonization with bacteria. And we'll come back to that a little bit more in the next lecture. And then we would want to facilitate low and slow fermentation in the gut rather than large and fast fermentation. So the good side here is that when we have an intact gut-blood barrier and that we have an intact barrier between the blood and the brain, then we may have a healthy state. But if we have this state down here, we may have a translocation of bacteria going across to the bloodstream and also translocation of toxins going across to the brain, potentially creating neurological damage. So these are illustration of the positive and negative sides of feeding a good diet versus a bad diet and in a bad condition. So let me summarize it finally like this: that the immature intestine is very sensitive to nutritional and microbial stimulation, but this stimulation and responses depend on diet type. We've seen that between mother's milk and infant formula. It also depends on when you feed it and when you start to feed parenteral nutrition, which is not beneficial. So the TPN versus enteral condition is important. Then also the age of the newborn is important. It's more sensitive with these optimal diets just after birth as it is later. And finally, the timing of birth, preterm versus term, is also very important. And even the birth process itself is very important for the responses that this newborn may have to the enteral diets. And at the moment, we are doing a series of studies on birth complications and then the responses to enteral diet. But let's get back to more details regarding the effects of the bacteria in the next lecture. So thank you very much for your attention.